Alright, so how does everybody? Some hard ones, a little harder, and some easy ones. This test is going to be I don't want to say a lot, but a good majority of it's probably going to be a lot of IT. And the only reason is because that's a lot of what it's just IT stuff. Stuff from lecture is going to correlate, so PCML, ALS, those are all up for grabs. So you got to know those tracks and what they say, what they do, and all that stuff. So what is this guy? ACA, right? The reason why it's ACA, which, did anybody put internal carotid? Now the reason why it's not internal carotid is because this is applicable, obviously this is Dr. Sprang, this is ACA. But, so right here we're at midline, right? And if we think about the anatomy, the internal carotid is not, I mean it's midline, but it's a little bit further on the outside, correct? So it's coming up, and we're saying midline, or on the sides of midline basically, and then we're splitting, and then the ACA comes and goes right up the middle, right? So we have to think that if this is a sagittal section, this right here would be what? This little right? This is singular gyrus. So what's supplying singular gyrus? So this would be ACA is coming up, and then it's giving off connections to supply this medial portion of the makes sense why it's not. So what cranial nerve growth?
9-10.
9-10. So what is this region? Is anybody confused? I want this kind of be like interactive, good questions, asked. Okay, so we're in upper medulla, obviously. So what would this guy be? It's kind of hard to see, but. Yeah, so we're starting from hypoglossal, and it's going to be more predominant a little bit lower, right? So where corticobulbar tract, it's hypoglossal, ipsilateral, bilateral, or conjugal. Hypoglossal is conjugal. Okay, anytime you damage the nerve or the nucleus, always remember you're going to see lower motor neuron deficits, right? Because that's where those lower motor neurons are. They're in that nucleus sending their axons out. So if you nick corticobulbar tract, then you have to think about, well, where's things coming from, blah, blah, blah. But it doesn't matter if it's bilateral, innervated, ipsilateral, conjugal. If you hit the nucleus of the nerve, you're going to see deficits on the ipsilateral side. Okay? And then it just matters what thing you're working on. So like tongue, if it's ipsilateral to tongue, it's going to be towards that lesion, right? These sides here.
Well, it's not that your voice keeps trailing off, right? I can't hear you. Your voice keeps trailing off.
Yes. I feel like
But he's talking about hypoglossal. I thought it was
okay. So like she said, except for when it's bilateral integrated. Well, it doesn't matter if you hit the nerve or the nucleus, right? So say trigeminal, right? So trigeminal is bilaterally innervated. If I knock out upper motor neurons in that descending innervation to that trigeminal, if I knock out one side, it doesn't really matter, right? Because the contralateral side is going to pick up, or the ipsilateral side is going to pick up if I knock out the other side. Does that make sense?
Yeah.
But if I hit the nucleus or the nerve, those are already innervated, right? So the ipsilateral and contralateral side have gone to that nucleus, and now from that one point, they're coming coming out. So if I hit that nucleus, I'm going to see deficits on the ipsilateral muscles of mastication. Does that make sense?
Yes.
And what kind of signs would you see? So you'd see fasciculations, atrophy, lower motor neuron. So where does this track originate? So basically where this will look. Okay, so what would this be? So this is corticospinal, right? And so where would this track originate from? Right? So it's contralateral. Yeah, contralateral primary motor cortex.
Can you talk louder?
So it's I can put on the mic.
Yes.
I just put motor
It's going to be
cortex.
how they ask the question. So whenever they say be specific, the more specific you are, it's not really going to prove through. I mean, unless you put the wrong thing. Like, I mean, you're super specific and you're like, oh, you know.
Well, do they want the histological?
No, unless they would have to say something like that. Like, I mean, you can put a million things here. You can be like, oh, well, it's from the, you know, I don't know. Well, you can be like, recent areas, 3, 2, 1. I mean, before, like, you could just put a bunch of stuff. But what they want here is like, where does it originate? I would say, for be specific, they always want you to put like a directionality. So, contralateral, ipsilateral, bilateral, those things. And then where does it originate? I would just put primary motor cortex. If you wanted to put from there or whatever, then you could, but I mean, I think that would just do it. Like, then I don't want you to put 15 things. Yeah.
So what was the answer for this one, just to be clear?
Just contralateral primary motor cortex. Hello. Sorry. Yeah. I hate the way my voice is. Okay, that's way low. Okay, that's so fun. Sorry, I'm like 80 now. I'm just gonna hold it down. All right, so what is this vascular structure? Straight sinus, right? Straight sinus, confluence, discitis, sagittal. I highly doubt they're going to ask a question like,
1 for 4.
where does this fluid come from? I mean, it might, but I highly doubt it because it's not super regular stuff. Other than that.
John,
Yeah,
will they ask for vascular structure or will they just say structure?
they'll say vascular structure.
Okay, they won't. Will they generally give us hints? Is it like an anatomy, say structure or muscle or vessel?
It kind of depends on like a space type thing. That was what Pat Now and Geringer would like kind of argue about. Pat Now likes to put structure, so if it's like the intrapeduncular system or something, she would put structure as opposed to Geringer who would put space. Well, Pat Now makes the text. So is that doing that? Okay. But yeah, most likely they're going to put vascular structure if they want you to say vascular structure. Other than that, they're going to say structure, or I mean, they're going to give you hints to what they want. If it's confusing, like if they point to a structure and it could be a bunch of different things, it's a vascular point to. Okay, so what is this structure or space? So what are we looking at? All right, so this is the head. These are the eyeballs, right? So this is the front of the patient. This is the nose. So we're coming at brain. So here we have our lobes forming, blah, blah, blah. Oh, right, we're in the middle, right? So we see our little Mickey Mouse ears. Looks like this. So this would be the midbrain, correct? Right, we see that? Okay. So this midbrain, so these would be our peduncles, right? So this space in between that's filled with this brightish color is going to be the peduncular cisterna. So interpeduncular, so it's in between the peduncles. Okay.
Could it be fossa or cistern?
Huh?
How do you know if they want fossa or cistern? 'Cause isn't there a fossa too there?
I think if you put either, they would count them both, right? Because I mean, the things that you can argue, they're probably going to count, right? So that way 50 students aren't coming up and they know. But if it says in the lab manual, it can also be called, something different, then you can put either or. I mean, I don't really know how to, like this, I honestly didn't use either one. You could argue both ways. So the way, I always tell my groups, the way I figure out if it's like T1, T2 weighted, I try to find spaces that I know are going to be filled with fluid, right? Because in a T2, what's the color of water or fluid? Bright, right? So if you see, and it's easier to see it when there's like a big old lateral ventricle, because then you're like, bam, that's white, oh, T2. So then you know if they show you another whiter spot, then you're like, oh, that could be fluid. Like that, oh, word. So that's how I look at it. So obviously this is pointing to something that's a lighter color, right? So these are dark. So these are all myelinated structures, and this is going to be a brighter color because it's filled with fluid, so cistern. All right. So what is this nucleus? Yeah. So substantia gelatinosa. And then what is the rex? Whatever. So it's 2, right? And on these, they're kind of hard to see. So what they're gonna tag is most likely 2, and what is the one in the middle? 10 over here. Yeah. They're gonna tag those. They might tag over here and have it like bilaterally and have a little curve here and a little curve there. And like, what is the?
Did they ever do 8?
What?
How would we know if they wanted like 8? Like Rex Lemonade. That one.
That's what I'm saying. Like, they're not going to show you stuff that's tricky. They're not going to be like, oh, where's Rex Lemonade 1? So, like,
What are we looking at?
substantia gelatosa or whatever. So this one's obviously easy to see because it looks like a big gelatinous substance, right? Substantia gelatosa. It looks gooey. So they're going to tag that one because you can see it.
Just
you can
put
idea it.
2. I did.
They're going to tag maybe these guys, right? Because you're like, oh, well, this is lower motor neuron nuclei area, so obviously, it's or 9. So.
Hey Jonathan,
Yeah.
are you going to post the answers online? I know you've mentioned you can't post actual PowerPoint, but are the answers going to be posted online?
She didn't say I could, so I guess
I got to go in a few minutes, and so I was just wondering if either maybe we could just run through these and just get an answer.
Also, I'm gonna come up here Saturday, because there's a couple people that can't make it tonight. So I'm gonna do it Saturday from like noon, but I'm not gonna do it here. I'm gonna do it in the library, probably in the breakout room, unless there's like a crap ton of people.
Okay.
But that way there's like 8 people and they can just watch it on TV or something. If you want to come tomorrow and hear the explanations for stuff,
Yeah,
you're more than
that's great.
welcome. But I can post the things.
Just the answers?
Yeah.
All right, thanks a lot. Appreciate it.
Okay, so we got that, right? So what level would this be? The lumbar, right? So why is it lumbar? So it's big. We got these little, we got these big old lateral enlargements happening because we have a lot of lower motor neurons. And you can start to see the cauda equina, which, is kind of a giveaway. But yeah, so. And like she said in lab, they're not going to be like, oh, is this T12 or is this L1? Like, they're not going to do that. Okay, so what is this?
Superior cerebellar.
SCA, right?
Yep.
Do they accept abbreviations?
Yeah.
Like
If it's an abbreviation that they use frequently, like PICA, AICA, PCA, MCA, ACA, yeah, perfectly. All right. So here we have what?